can we really justify it? I mean, as philosophers, we're always questioning things like how we know stuff and, how we make sense of the world. But can we truly justify drawing conclusions about things we haven't even seen? Basing those conclusions solely on what we have observed.
Hmm. It really gets at the core of reasoning and knowledge, doesn't it?
Yeah.
Like, what are the legitimate ways to move from specific observations to these, grand general laws? And how do we even form expectations about the future?
That's exactly it. And, for our listeners out there, you folks who thrive on these really deep dives into the foundations of knowledge, this problem of induction, that's what we're tackling today. This is a big one, right? Like
Yeah.
how we learn and predict and how reliable that process even is.
Yeah, and it's not just some theoretical puzzle either.
Yeah.
It has huge implications for how we approach science, how we make decisions in our daily lives, all sorts of things.
Right. And to really get into the nitty gritty, we're diving deep today into a really fantastic piece of philosophical work. We've got excerpts from the Stanford Encyclopedia of Philosophy's entry on the problem of induction. It's like having this brilliant colleague, right? Someone who's laid out the historical context in Hume's original argument and all the different ways philosophers have wrestled with it over the centuries.
Yeah, the SEPI entry does a great job of showing how influential Hume's take on this problem has been. I mean, it's a problem that's been debated for ages and still is so relevant today.
Absolutely. So that's our mission today, to grapple with David Hume's problem of induction and explore all the different ways people have tried to tackle it. So let's start with a bit of historical context.
Yeah.
Yeah.
Where was Hume coming from intellectually when he first laid out this problem? Okay, well, Hume was a major figure in the early modern period, really focused on how the human mind works and its limitations.
Yeah.
And one of his big ideas was that all of our thoughts, he called them ideas, right? They all come from our sensory experiences, the things he called impressions. So basically our thoughts are built on these simpler sensory building blocks.
So like the feeling of heat is an impression, and then the concept of fire, that's an idea built from those impressions of heat, the sight of flames and all that.
Exactly. And Hume argued that the main way we go beyond those direct senses and memories to understand the world is through cause and effect.
Yeah.
We see one event following another and start to expect that pattern to continue. Like seeing gunpowder and expecting an explosion. It's a super fundamental link between what we've experienced and what we expect will happen.
Right. It seems so natural to us, doesn't it? Like we just assume cause and effect is this basic law of the universe.
It does seem intuitive.
Yeah.
But Hume, being the sharp mind that he wasn't content with just intuition. He wanted to know what justified this belief in cause and effect.
Yeah, because it's not like a logical necessity, right? It's not like a triangle having three sides. It's something we observe happening over and over.
Exactly. And in his treatise, that's where he really digs into this and argues that this idea of cause and effect, it can't be proven through pure logic or what he called a priori knowledge. It's entirely based on experience, on seeing those events happen together consistently. And he had this great phrase for it, constant conjunction.
So we expect gunpowder to explode not because it's logically impossible for it not to, but just because that's what we've always observed.
Right. And this is where we hit the problem of induction head on here. Hume asks, what exactly justifies this leap from what we've observed to what we haven't? If it's a reasoned argument, what are the premises? What's the logic behind it? He even lays out the general form of these inductive inferences. Things like, I've seen this object always followed by this effect. So I assume similar objects will lead to similar effects in the future.
Right. Like the sun rising every day makes us think it'll rise tomorrow.
Yes. Exactly. And Hume's not buying it, not without a solid justification. He's saying that if we're using reason to make these inductive leaps, then there has to be some underlying principle that makes it work. And in his treatise, he spells it out. He says the principle is that instances of which we have had no experience must resemble those of which we have had experience, and that the course of nature continues always uniformly the same.
That's a mouthful, but basically what we call the uniformity principle, right? The idea that the future will be like the past, at least in the ways that matter.
Right, the UP for short. It's this bedrock principle for all of our empirical reasoning about the world.
So Hume is taking aim at this foundation, and his argument is pretty ingenious. He sets up this dilemma, basically two ways we might try to justify the UP, and then he shows how both of them fail.
Yeah, classic philosophical move, right? Cover all the bases and then demolish them one by one. So to understand Hume's dilemma, we have to get into this distinction he makes between relations of ideas and matters of fact.
Okay, break that down for us.
So relations of ideas, those are things we know through pure thought, like math or logic. Their opposite is a contradiction, right? Like a square circle doesn't make sense. Matters of fact, those are about the world we experience. Their opposite is totally conceivable, even if it's unlikely.
So like 2 plus 2 equals 4, that's a relation of ideas. The sun will rise tomorrow, that's a matter of fact, even though we're pretty darn sure about it.
Exactly. And Hume's point is that any justification for the UP has to fit into one of these two categories. Either it's based on demonstrative reasoning about relations of ideas, or it's based on moral or probable reasoning about matters of fact.
So first he goes after demonstrative reasoning, right? Trying to prove the UP with pure logic.
Right, and he's, look, demonstrative reasoning only works for conclusions that are logically necessary, like those relations of ideas.
Mm.
But the course of nature changing, that's totally conceivable. It's not a logical contradiction to imagine a future where bread is poisonous or the sun doesn't rise.
Mm-hmm.
Those things might be unlikely, but they're not impossible in the same way a square circle is.
Right, we can picture those things happening even if it be really weird.
Exactly. So, since the opposite of the UP is conceivable, demonstrative reasoning can't prove it's true. That's the first horn of Hume's dilemma.
Okay, so pure logic is out. What about trying to justify the UP through experience, through probable reasoning?
And here's where it gets really tricky for anyone who wants to base knowledge on experience. Hume argues that any probable reasoning about matters of fact, any argument that uses past experience to predict the future, already relies on the UP. It's like using the UP to prove the UP, a classic circular argument. You're assuming the very thing you're trying to prove.
So if I say the sun will probably rise tomorrow because it's always risen before, I'm already assuming the future will be like the past.
Exactly. It's a vicious circle, no way out.
So both pure logic and appeals to experience, they both fail to provide a solid, non-circular foundation for believing the future will be like the past. So what's left? Like if reason can't justify these inductive inferences, what does Hume say is going on in our minds when we make these leaps?
Well, in his treatise, Hume suggests it's all about the imagination. It's this natural association of ideas that gets stronger with repeated experience. So we see bread and nourishment together so often that our minds just automatically link them.
It's like our brains are wired to see patterns and make those connections.
That's right. But later on in his inquiry, he refines this idea and puts more emphasis on custom or habit. He's saying it's this instinctual thing like feeling pleasure or pain. It's not some conscious, rational decision process.
So it's not that we're consciously thinking through these inductive inferences every time. It's more like a pre-programmed response almost.
Yeah, pre-established harmony between how our minds work and how the world works. It's a pretty humbling view of what we might think is this rational capacity.
Right, so Hume's not saying we don't make inductive inferences. He's questioning whether those inferences are actually based on reason. It's a challenge to philosophers, right, to try and find the logic behind this seemingly fundamental part of how we think.
Exactly. He's raising this profound question that's still being debated today, and all the different attempts to answer it. That's what makes the problem of induction so fascinating.
Okay, so that's Hume's initial take on the problem. But the Sep Pippi entry goes deeper, right? It talks about how philosophers have tried to formalize Hume's argument to make the logic of it even clearer. So how does that formalization work?
Well, these formal reconstructions, they try to boil Hume's argument down to its core logical structure. Often they focus on a really simple example of induction, like all observed as have been B's, so the next A will also be B.
So like every swan I've seen has been white, so the next one I see will probably be white too.
Right, classic enumerative induction. And the formalization lays out the key premises of Hume's argument. First, there's the idea that any knowledge about the world has to be either demonstrative or probable. That's Hume's fork. Then the argument says any justification for this kind of inductive inference has to use one of those two types of reasoning. And then it goes on to show how both demonstrative and probable arguments for the UP end up failing, either by being impossible to prove or by being circular.
And the conclusion, of course, is that if you can't prove the UP and induction depends on the UP, then induction itself isn't rationally justified.
Exactly. The formal reconstruction really lays bare the logic of Hume's dilemma. It also highlights how our understanding of those terms, demonstrative and probable, has shifted over time. Early on, some people thought they just meant deductive versus inductive arguments, but the SAP entry makes it clear that Hume meant something broader.
Right. It's not just about the structure of the arguments, it's about where the justification comes from, whether it's a priori knowledge or empirical evidence.
Exactly, and the SEPI entry also points out that you can actually rephrase Hume's argument to directly target induction itself without even mentioning the UP. The core problem remains the same. How do we justify going from observed cases to unobserved ones without relying on either logical necessity or the very pattern we're trying to justify?
So the formalization helps us see the different parts of Hume's argument, but the big question still remains. Did Hume think this was just a description of how our minds work, or was he actually saying induction is irrational?
Yeah, that's a huge debate among Hume scholars. Some think he was just explaining our natural tendency towards induction, while others think he was making this deep skeptical point about the limits of reason.
So even figuring out what Hume meant is a philosophical puzzle in itself. Okay, so we've laid out Hume's challenge now. Let's dig into some of the responses. And the Seppi entry organizes them really nicely. So let's start with the first horn of Hume's dilemma, the claim that there's no a priori justification for induction. What are some ways philosophers have tried to tackle that?
Well, one of the most famous and influential responses came from Kant, who basically rejected Hume's whole premise that a priori reasoning can only deal with relations of ideas. Kant argued that there's this whole category of knowledge called synthetic a priori.
Synthetic a priori knowledge, that's a mouthful, but it means knowledge that's both necessary and universal, like a priori knowledge, but also tells us something new about the world, like synthetic knowledge. That's a pretty mold idea.
It is Kant basically flipped Hume's view on his head. Instead of saying we learn about cause and effect from experience, Kant said that our minds already have these built-in categories of understanding, including causality, and these categories shape how we experience the world in the first place.
So it's not that we observe cause and effect out in the world, it's that our minds are pre-programmed to see the world in terms of cause and effect.
Exactly. And that's how Kant tried to get around Hume's claim that you can't use a priori reasoning to establish things about the world. He said that these a priori categories are necessary for any coherent experience at all.
So Kant's response is like a total overhaul of how we think about knowledge and experience. Pretty radical stuff, but what about more recent attempts to find an a priori justification for induction?
Right, so another approach focuses on what's called the nomological explanatory solution. Philosophers like Armstrong, Bonjour, and Foster have defended this view. They say that inference to the best explanation, or IBE, that's the key part of a priori justification, and it's different from regular inductive generalization.
IBE, that's the idea that we should choose the hypothesis that best explains the evidence we have. So how does that fit into justifying induction?
The argument goes like this. First, they say that a lot of the regularities we see in the world, they need to be explained by some underlying causal laws. It's not enough to just say they've always happened together like Hume did. Second, they say that the simplest explanation, the one that just extends the observed pattern to unobserved cases, that's often the best explanation.
So instead of just saying bread has always nourished me, so it probably will, again, you're saying there's some law of nature that makes bread nourishing.
Right, but the problem is, how do you know that law exists? How do you know it applies beyond the cases you've observed? Critics of this view say it's still relying on some kind of uniformity principle. It's still assuming the future will be like the past.
So it's not clear that IBE actually escapes Hume's circularity problem.
Exactly. And there are other issues too, like why should we always prefer the broadest of most universal explanation? Sometimes a more limited explanation might be better. And that leads us to another major attempt to tackle Hume's first-horn Bayesian probability theory.
Ah, Bayes' theorem, the math of updating beliefs based on new evidence. So how does that come into play here?
The idea is to use the a priori rules of probability to show that the premises of an inductive argument can make the conclusion highly probable, even if it's not absolutely certain. So, like imagine you're drawing balls from an urn and you want to figure out the ratio of different colored balls inside Bayes, gives you a way to update your initial belief about that ratio based on the balls you've drawn.
So you start with a prior probability based on whatever you know beforehand. Then you incorporate the evidence and you get a posterior probability that tells you how likely your belief is.
Exactly. And the math itself is a priori, right? It's based on these logical axioms. So could that be the a priori justification Hume was looking for?
It seems promising, but I'm guessing there are some catches.
The Seppi entry lays out several challenges to seeing Bayesianism as a purely a priori solution to Hume's problem. One issue is how you interpret probability itself. Some interpretations are more a priori, like logical probability, but others are more subjective, like degrees of belief.
So depending on how you define probability, the whole argument might shift.
Right, and another issue is the model you choose to represent the situation. Like with the urn example, you're assuming the balls are drawn randomly and independently. Is that always a safe assumption?
The urn is just a model, right? The real world might be a lot messier.
Exactly. And then there's the big one. How do you choose those initial prior probabilities? Like, before you see any evidence, what should your beliefs be? There's this idea called the principle of indifference, which says if you have no reason to favor one hypothesis over another, you should give them equal probability. But that principle has run into a lot of problems. It can lead to paradoxes and contradictions.
So it's not as straightforward as it might seem.
Right. And then there's this whole fields of inductive logic that tried to come up with a priori probability functions that could provide a logical basis for induction. But what they found is that there's no one right way to do it. There are all these different possible inductive methods depending on the axioms and parameters you choose. Like one important concept is exchangeability, the idea that the order you observe things in doesn't matter. Definetti's theorem shows how exchangeability relates to the idea that the future will resemble the past.
So the way you set up the problem really influences what counts as good inductive reasoning.
Exactly. And ultimately, the Bayesian approach runs into the same problem as all the others. It still relies on some empirical assumptions about the world. So while it's a super useful tool for dealing with uncertainty, it's not clear that it offers a purely a priori escape from Hume's dilemma.
Okay, so the quest for a definitive a priori refutation of Hume seems to have hit some snags. What about approaches that are more like partial justifications or justifications that depend on certain conditions?
Right, some philosophers say that even if we can't completely justify induction a priori, we can still find parts of it that are logically valid given certain assumptions. So like Howson argues that inductive inferences are justified if they're sound within a framework that includes the right background knowledge.
So it's like saying the process of updating beliefs according to Bayes' theorem is logically sound, but the initial beliefs themselves might not be a priori justified.
Exactly, and this idea connects with some really interesting stuff in machine learning and AI. There's this idea called the no free lunch theorem, which shows that no single learning algorithm can be the best for every possible task unless it makes some a priori assumptions about the data.
So even machines need some kind of starting point, some built-in biases to learn effectively.
Exactly, and this kind of echoes Hume's first horn. There's no purely logical guarantee that a learning algorithm that just relies on data will always succeed, because there might be situations where those biases lead it astray.
So to learn anything, you need some pre-existing ideas about how the world works.
Right, and while those no free lunch theorems show the limits of pure inductive learning theory, also provides these model relative a priori guarantees. Like you can prove that a certain algorithm like Bayesian updating will work well if your model of the world is accurate and your prior probabilities are reasonable.
So it's a justification within a specific framework, not a universal justification.
Exactly. And then there's this other interesting approach called the combinatorial approach championed by philosophers like Williams and Stove. They try to justify induction a priori using the proportional syllogism and the law of large numbers.
Remind us what the proportional syllogism is again.
It's basically saying that if most members of a group have a certain property, and you pick one member at random, that member probably has that property too. So like if most swans are white and you see a swan, it's probably white.
Right, that makes sense. So how do they apply that to induction?
They argue that because of the law of large numbers, most large and representative samples will be pretty similar to the whole population. So if you observe a sample with a certain frequency of some feature, you can use the proportional syllogism to say that the whole population probably has that feature too. So they say this line of reasoning gives you an a priori justification for induction.
But doesn't that depend on having a representative sample? If your sample is biased, your conclusion could be totally wrong.
That's one objection. And while they say you don't need to know for sure that a sample is random unless you have a reason to think it's biased, there's a deeper problem. The real issue is in that last step where you go from the observed sample to the whole unobserved population. Philosophers like Hacking and Marr have pointed out that high probability can mean two different things.
So it's like saying there's a high probability that a coin will land on heads 50% of the time, versus saying that for any given coin flip, there's a high probability it will land on heads.
Exactly. The law of large numbers tells you about the long-run average, but it doesn't tell you about the likelihood of any specific case. So the combinatorial approach, while it tries to get around the need for prior probabilities like in Bayesianism, it might actually be making implicit assumptions about the uniformity of the population, which would make it circular too. So it's not widely accepted as a successful a priori solution.
Okay, so lots of clever attempts, but no clear knockout punch against Hume's first horn. So let's move on to the second horn, the circularity problem, trying to justify induction by using induction. How have philosophers tackled that one?
One way they've tried to address it is by saying that the circularity in these inductive justifications, it's not necessarily a deal breaker. This is the idea behind what are called inductive justifications of induction.
So you're justifying induction by appealing to its past successes. That sounds pretty circular on the face of it.
It does, and Hume himself pointed that out. But some philosophers say that this kind of circularity, called rule circularity, is different from premise circularity, and maybe not as bad.
Okay, so rule circularity is using a rule to justify itself. How is that different from premise circularity, and why might it be okay?
The idea is that maybe you don't always need a completely independent justification for the most basic rules of reasoning. Like, take modus ponens in deductive logic. Lewis Carroll has this great dialogue where a tortoise challenges Achilles to prove modus ponens. And it turns out you can't really do it without already assuming modus ponens is valid.
So it's like saying some rules are so fundamental that you can't justify them without already using them.
Exactly, and the argument is that induction might be one of those fundamental rules. So even though it's circular to justify it by appealing to its past successes, that might be unavoidable and not necessarily a fatal flaw.
It's like saying induction is so basic to how we think that we can't step outside of it to justify it.
Right, and some philosophers who are externalists about justification, they say that as long as induction actually works, as long as it reliably leads to true beliefs, then it's justified even if we can't give a non-circular argument for it.
Yeah.
Others say that for these super fundamental rules, self-endorsement might be the best we can hope for.
So it's not about convincing a skeptic, it's more about showing that induction is consistent with itself.
Right, but of course there's a problem with that. What about unreliable rules? Like imagine a rule that says the future will be the opposite of the past. Couldn't that also be self-justifying in a circular way?
If things consistently went against our expectations, wouldn't that just prove that rule was right?
That's a good point, and the Tupino entry acknowledges this problem. Just because a rule can justify itself doesn't mean it's actually a good rule. So rule circularity might not be enough to distinguish between reliable and unreliable inductive methods. But defenders of inductive justifications like Papineau, they say that even if these arguments don't convince skeptics, they can still help us make our beliefs more coherent.
So it's like a way of checking that our inductive practices are internally consistent, even if we can't prove they're objectively true.
Exactly. And another really interesting approach to Hume's second horn is to question whether there even is a single rule of induction that needs to be justified. This is the no rules view advocated by philosophers like Okasha and Norton.
So instead of looking for a justification for the UP, they're saying there's no UP at all.
Not in the sense of a universal rule that applies to everything. They point out that the future only resembles the past in certain ways, not always. Like just because I've had birthdays every year of my life doesn't mean I'm guaranteed to have another one.
Right, so how do you know which regularities are projectable and which ones aren't?
That's a great question. And it leads us to Goodman's famous new riddle of induction and his concept of GRU. So imagine we've seen a bunch of emeralds, and they've all been green. We naturally assume future emeralds will also be green. But Goodman said we could just as well have been observing GRU emeralds, emeralds that are green before a certain time and blue afterwards. All our past observations would be consistent with either hypothesis.
So how do we know whether to project greenness or gruness into the future?
That's the riddle.
Yeah.
The no-rules view says that each inductive inference depends on specific background knowledge about the domain you're dealing with, not on some general principle like the UP. So instead of having one big circularity problem, you have a bunch of smaller justifications, each based on different empirical claims.
So it's like saying instead of justifying induction in general, you have to justify each inductive inference separately.
Exactly, and this can lead to an infinite regress of justifications where each one depends on another one. And whether that's better than circularity is up for debate. Some philosophers say an infinite regress is just as bad as a circle and leads to skepticism. Others, like Norton, say that sometimes the regress might end with basic facts that don't need further justification. Okasha has even suggested that an infinite regress might be preferable to a closed loop of justification.
So it's a way of trying to break out of Hume's dilemma, even if it creates new philosophical challenges.
Exactly, and the S-Epidid points out that the no-rules view has its own issues too, like is Bayesian conditionalization a kind of general rule of induction, even if it's probabilistic? And can you really describe induction without appealing to any underlying principles at all? Norton's material theory of induction tries to do that, but it's still a debated topic.
Okay, so we've seen how philosophers have tried to tackle the a priori and circularity problems head on. But there's another category of responses in the SF entry, right? Ones that try to redefine what justification means.
Right, some philosophers question whether we even need a traditional argumentative justification for induction. Like Wittgenstein was skeptical of the whole idea of looking for grounds for these fundamental inferences. He had this idea of hinges of inquiry, these basic principles that we just operate within. They're not things we prove or justify. They're the starting point for our reasoning.
So it's like saying some things are so fundamental to how we think that we don't need to justify them.
Exactly. And Crispin Wright built on that idea with his concept of entitlement, a kind of rational warrant for believing something that doesn't require a step-by-step argument. He thinks the UP might be one of those entitlements. Other philosophers have just gone ahead and made principles of induction into axioms like Russell and Burke's did. But the problem with those approaches is that they seem to just dodge Hume's challenge instead of actually answering it. Like, say, we just have to believe in induction because we have to.
And that doesn't feel very satisfying philosophically, does it?
Not really. And then there's this really influential view called the ordinary language dissolution of the problem put forward by Strawson. He said that asking for a general justification for induction is like asking if the law is legal. Our very standards of justification are already based on induction.
So it's like saying when we ask if an inductive inference is justified, we're really just asking if it follows the rules of induction.
Exactly.
Yeah.
Strawson argued that it's analytically true, that it's reasonable to base your beliefs on the evidence, and that observing enough cases of irregularity is strong evidence for a general claim. So asking whether induction is reasonable is kind of like asking whether it's reasonable to be reasonable according to our own standards.
It's a clever way to reframe the problem, but does it really address Hume's worry about whether induction actually leads to true beliefs?
That's the main criticism of Strawson's view. Just because we define rationality in terms of induction doesn't mean induction is guaranteed to get us to the truth. Even Strawson himself acknowledged that there's a separate question about whether induction will continue to work in the future. Hume's main concern was about the reliability of induction, and Strawson's argument, while interesting, doesn't really answer that.
Okay, so maybe you can dissolve the logical paradox, but the underlying question about whether induction is truth-conducive, that's still there. What about pragmatic justifications?
Right, so Hans Reichenbach developed a pragmatic justification for induction. He said we don't have to show that induction always leads to true beliefs. We just have to show that it's necessary for achieving a certain goal, which is finding regularities in the world and making successful predictions.
So it's like saying even if we can't be sure induction is always right, it's the best tool we have for making sense of the world.
Exactly, and Reichenbach had this idea called the straight rule of statistical induction, which basically says you project observed frequencies into the future. So if you've seen that 90% of swans are white, you predict that 90% of future swans will be white. He argued that if there are stable regularities in the universe, induction is the only way to find them in the long run.
But couldn't other methods also find those regularities? What about just guessing or using some other kind of pattern recognition?
That's a criticism people have raised, and Reichenbach tried to address it by saying that induction is the simplest and least risky method. And he argued that we probably need induction itself to test whether any other method was better. Like if someone claimed they could predict the future better than induction, we'd have to use induction to see if they were right. But there are still questions about whether he defined induction's goal too narrowly and whether a purely pragmatic justification really answers the question of why we should trust individual inductive inferences.
It seems like it's saying induction is the best bet we have, but it doesn't guarantee that any specific prediction will be true.
Exactly. And formal learning theory, you can think of that as a more modern and mathematically rigorous version of Reichenbach's program. It focuses on how reliable different learning methods are in terms of converging on the truth given enough data. It also looks at things like how fast a method learns and how often it changes its mind. Some researchers in this field say that Occam's razor, the idea that simpler hypotheses are better, could be pragmatically justified because simpler methods tend to learn faster and make fewer mistakes.
So it's like saying if you want to be a good learner, you should prefer simpler explanations.
Right. And Steele has even argued that you can justify the principle of induction itself in a means-ends way. He says it's both necessary and sufficient for achieving logical reliability, which is basically the ability to get to the truth given the right goals. But these justifications, they often depend on the specific hypotheses you're considering and the data you have. So it's not clear that they solve Hume's original problem or Goodman's new riddle of induction.
So these approaches are more about justifying learning strategies in general, not individual predictions.
Exactly. And finally, there's this approach called meta-induction, developed by Schertz. This one distinguishes between object-level induction, which is what we usually think of as induction, applying it to events and properties in the world, and meta-induction, which is applying induction to the track records of different prediction methods themselves.
So it's like using induction to figure out which inductive methods are the best.
Exactly. Schertz argues that the ultimate goal of induction is to make successful predictions both in the short term and the long term. and he points to work in regret-based learning that shows there are meta-inductive strategies that do really well in the long run across lots of different situations. His weighted majority algorithm, or WMI, is one example, and he says this gives you an arbitrary means ends justification for using WMI. Then he says that since object-level induction has generally been more successful than other methods throughout history, it's meta-inductively justified to keep using it.
So we're using induction to justify induction. It's a bit mind-bending, but it's an interesting approach.
It is, but there are some limitations to it too. Like the results for WMI usually only apply to a finite number of methods. And it's not clear how the justification for the meta-level strategy translates to a justification for every specific prediction we make using object-level induction. So it might justify a general approach of favoring methods with good track records, but not necessarily every single inductive inference.
Okay, so even meta-induction has its complexities.
Right.
It seems like escaping Hume's shadow is a really tough task.
It is. And as the SCP entry concludes, some philosophers have just accepted Hume's skeptical conclusion that induction can't be rationally justified. So then the question becomes, how do we reconcile that skepticism with the fact that we obviously rely on induction all the time in our lives and in science?
Right, it seems like we can't just stop using induction, even if we can't definitively prove it's right. Karl Popper tried to argue that science is actually deductive, that it's about proposing hypotheses and then trying to falsify them. But that view has its own problems, too.
Yeah, and Hume himself, even though he was a skeptic about induction, he seemed to think that we're just naturally inclined to use it. It's so ingrained in how we think that we can't just abandon it because of some philosophical doubts. So maybe the real issue isn't about finding an airtight proof for induction, but about understanding the limits of reason and the role that non-rational factors like habit and instinct play in how we form beliefs about the world.
So after all this discussion, we're back to the big question: can we truly justify relying on past experience to guide our understanding of the future? And it seems like the answer is still very much up for grabs.
Yeah, and what's so intriguing for us as philosophers is that Hume's problem, it's not going away. It forces us to think about the foundations of knowledge itself, and that's why it's still so central to epistemology and philosophy of science. The sheer variety of responses it's provoked shows how deep and difficult the problem is. And as you said, even those who accept some form of skepticism, they still acknowledge that we can't really function without induction.
So here's a final thought for you, our listeners. If our most basic way of understanding the world beyond our immediate experience, if that's not fully rationally justifiable, what does that say about knowledge itself? Does it mean that induction is less valuable or less necessary? Or does it point to some deeper, maybe non-rational basis for how we make sense of things? It's a question worth pondering.
It really is, and we encourage you to explore the ideas and philosophers we've talked about today. The problem of induction, it's not just an abstract puzzle. It has real consequences for how we do science, how we live our lives, how we understand ourselves. So keep thinking, keep questioning, and keep exploring.
Exactly, and that's what philosophy is all about. So thanks for joining us on this deep dive, and we'll see you next time.
See you then.